This is freezing point depression, and the equation for freezing point depression that we're using is delta T equal I KFM. But sometimes you see it this way, delta T F equal negative I KFM. And the deal is, what you should be asking is, what's with this negative sign here? And here it is. The reason is the delta T for delta T is always the new melting point minus the original. But since it's a freezing point depression, this is always a bigger number and this is smaller. And that's always going to make delta T negative for freezing point depression. So the easy way to do it, and how your book does it, is it ignores the signs on these and just says the T has to go down. It has to be more negative than the original freezing point. That's why it's called freezing point depression. It gets smaller. So I'm going to set up a problem for us to do. So here's our problem, and these are a little bit difficult. You're going to have to do some thinking on these. I chose two problems that were difficult, figured you could get the easier ones. So we're going to take 2 grams of unknown, and it reduces the freezing point of 75 grams of benzene. That implies they threw it in 2 grams of solute in 75 grams of benzene. And it reduces it from 5.53 degrees Celsius, that's the normal freezing point of benzene, and to 4.90, the new freezing point. And what is the molar mass of the compound? Kf equal 5.12. So we start writing down stuff. The mass of the unknown is equal to 2.00 grams. Mass of benzene is equal to 75 grams. That's our solvent. Kf equal 5.12 degrees Celsius per mole unit. The normal boiling point, T boil equal 5.53 degrees Celsius, and T depressed, that's how much, the one that goes down, 4.90 degrees Celsius. The plan here is to use freezing point IKF times the molality. I'm going to use delta T and Kf and I to calculate the molality. That's what I'm after. And from molality, I can get moles because it has units of moles per kilogram. Okay, so delta T is equal to 4.90 minus 5.53, and that equal negative 0.63 degrees Celsius. Well, we just drop that negative sign and make it 0.63 degrees Celsius on that. And so now I have delta T. I'm going to move it over here because I don't have a lot of room. I have delta T equal IKFM, and so delta T is 0.63 degrees Celsius. I equal 1. We're assuming it's a molecule. 1. Kf is equal to 5.12 degrees Celsius per mole unit, and we can calculate the molality. I'll put that in red over here. And so our molality equal 0.63 divided by 5.12, and I get 0.1230 molal. And that is units of 0.123 moles of our unknown per 1 kilogram of solvent, benzene. The second part of this, that's actually the third. This is the first part, calculating delta T, then calculate the molality, and now I'll calculate moles from the molality. I have 75 grams of C6H6, and I'll multiply by 0.123 moles of unknown per kilogram of C6H6, and I got to convert kilograms to grams. 1 kilogram, 1,000 grams. So 75 times 0.123 divided by 1,000 equal 0.00922. And finally, I know the mass. It's up here somewhere. If I can drag this 2.00 grams of unknown. That's the mass I have. So I can calculate the molar mass because I have the moles of unknown. So all I have to do is divide the 2.00 grams of unknown by 0.00922 moles of unknown. And I get 216.9 grams per mole. So those are two of the hardest problems you can do that I've showed you how.